Fairly easy lesson today. We're going to take the individual types of angles that we talked about yesterday. What were those different types of angles, by the way? I seem to have forgotten. Anna, what do you got for me?
What?
Different types of angles.
Acute.
Beautiful. Acute angle is what now? I forget.
90 degrees or less.
Close. Less than 90.
Oh, less than 90.
Okay, that's acute.
And then right angle, which is 90 degrees.
Perfect.
And then obtuse, which is 90 degree or more, but less than 180.
Good. Greater than 90, less than 180.
And
Can't
then
be 90.
Straight and
We talked about straight and
I can't remember that.
Oh,
And-
reflex.
and zero.
0.
But we're not going to deal too much with straight and zero. We're focusing mainly on obtuse, right, and acute. We're going to take those angles and pair them up now. So those were types of angles. These are pairs of angles, which is exactly what that says. Okay, so 5 pairs of angles today. They all do different things. They all have different names. First one, adjacent angles. These are the easiest. They're just 2 angles that are next to each other. However, there's a little bit of trick in there. They have to share a common vertex. They have to share a common side. Okay, the reason we need that is because we want to eliminate scenarios like these. Okay. So for instance, this and this are not adjacent angles. They share a common vertex, but not a common side. Also, notice the notation I'm using. This has 1 mark on it, the other one has 2, therefore I'm implying with that that they're not equal. If they both had this, then I would be saying that that angle is equal to that angle. Okay? Common vertex, common side. Any problems? No? Good. How many pictures, how many angles in that picture again? 3, correct. 3. Tegan, name them. Name the 3 angles in that picture.
Angle RQS.
That's one of them.
Angle RQP.
Uh-huh.
Oh, and angle PQS.
Perfect. Okay. Somebody didn't turn their phone off. Who's number 9? I got it. I fixed it. We're good. I just turned it off, so when you're done, make sure your phone turns back. Number 2, vertical angles. So I think at some point yesterday, this idea came up when we were trying to define an angle. What if we just cross 2 lines? Well, I did that for this scenario. And when you cross 2 lines like that, it generates 4 angles. It'll always generate 4 angles. And I've labeled those 4 angles as 1, 2, 3, and 4. The vertical angles are the angles that are across from each other. It has nothing to do with vertical like up and down vertical. It has everything to do with the fact that the angles are across from each other. I don't know why they're called vertical angles, but they are. So as it says, 1 and 3 are vertical angles, 2 and 4 are vertical angles. Tommy. Wait, hold on, Mary's question.
It's not really a question.
I'll come back to you in a second. It's
Oh,
not a
aren't-
question, it's a statement, confession.
Aren't vertical angles like the ones that are opposite each other equal to each other?
It's funny you should ask that question, because I was gonna just ask that same question to Tommy. Hey Tommy, what's the relationship between angle 1 and 3?
Forgot the word. Oh, they're vertical angles. Or they're not adjacent. Maybe, or they.
Well, they are are vertical angles, because it says right there 1 and 3 are vertical angles, but do you really think I'd ask you a question where the answer is written on the board?
I don't know.
I might. But you used a different word there. What was that other word you used?
Adjacent.
Is that what you said?
You said not. Okay.
You said non-adjacent, which means they're not adjacent.
Yeah.
Are 1 and 3 adjacent angles? Or are they non-adjacent angles?
They're non-adjacent.
Perfect.
Okay.
What else do you know about 1 and 3?
They're vertical angles.
We said that already. Good. And if I ask you again and you tell me they're non-adjacent, I may turn violent.
Okay. They're acute.
They are acute.
Wow.
Good. Yeah. And what would that make 2 and 4?
Obtuse.
I thought you were going to say vertical angles. Okay, so let me ask my question again. What's the relationship in the measures of angles 1 and 3?
They're the same.
They're the same. Now here's the important question. Why? Does everybody agree that angle 1 and angle 3 are congruent?
Yeah.
Okay, good. Why? Turkey boy?
If you look at the lines and almost think of them as two straight angles,
Well,
and
you don't even have to do that. They are straight angles.
right, so two.
That's like saying if I look at you and think of, just imagine that you're Sterling. Well, you are Sterling, so therefore I don't have to imagine it.
So 2 plus 3 equals 180.
Okay, let me write this down. I'm a little slow on the uptake. Angle 2 plus angle 3 equals 180. I like that. We talked about that going over the homework there. Okay, we have a name for that coming up in a later slide. Back to you, sir.
And angle 1 plus angle 4 is 180. And since there's a line going through, I lost my train of thought.
You started so strong too. I'm like, he's got this. Max, you want to help him out?
Then also angles 1 and 2 equal 180, and same with angles 3 and 4.
Are we all good with this idea?
Yes.
Great. Now what? How does that prove that 1 and 3 are equal?
You
Okay.
take the equation with angles 2 and 3 and 1 and 2.
This one and this one?
Yeah,
Uh-huh.
and then you see that, well, angle 2 plus angle 3 equals 180, and then angle 2 plus angle 1 equals 180, so angle 1 and angle 3 have to be equal.
Well, let's throw the extra step in there. Angle 1 plus angle 2 must then equal angle 2 plus angle 3. If they both equal 180, then they have to be equal to each other. Then what?
Then you solve it, well, yeah.
Subtract the same thing from both sides and we get 1 equals 3. And we can do that with the combination of angle 2 and 4 also, but what we find out is that if angle 1 is congruent to angle 3, then angle 2 has to be congruent to angle 4. Congratulations, you just did your first proof. And we'll give a name to what we just talked about. Today I just wanted you to understand or be able to identify vertical angles in a picture. We'll talk about the fact that they're equal and use that to solve problems later on. Okay, that's number 2. Third type, linear pair. Notice, same picture, I'm just picking out 2 different angles. So in the previous picture, I picked the angles across from each other. In this one, I'm picking the angles that are next to each other. Tommy, what are they called when they're next to each other?
They're adjacent.
Attaboy.
Wow.
Why do you seem so surprised by your own correct answers?
I don't know. I thought I would have forgotten the word by now.
What are you, a goldfish?
Yeah.
Short memory span?
You like this class? What's the reason?
I hate all my classes. I hate this job. I hate it. I hate life.
You guys don't have a job. You can't hate your job.
I'm sorry?
Not you. I said they don't have jobs, so they can't hate their job. You said you can't.
Well, you know, you gotta have jobs. I mean, being a student is pretty much full-time and
Yeah.
you gotta work at it.
I'm
You
being
get
forced
paid
to be
for
here.
it.
You don't have to have
Oh,
a
you
job.
get paid,
I have
alright,
to be
but
a student.
You get paid when
What's that?
We
You
get
don't have to
paid
have a
with
job, you have to
brain.
be a student.
Like smart people.
Yeah, so kind of, it's more like slavery.
Yeah, exactly.
Yeah.
Like I can leave my job, I can choose not to do this
I mean,
anymore.
I guess
and
I
go
could
sit
drop
home and play
out now.
video.
No.
No, you
technically,
can't.
You have to wait till you're 16.
Well,
You gotta be 16.
whatever.
Now, when you turn 16, that's a different story, but now, yeah, you are pretty much a slave.
1 year from next Thursday.
When you
You got a big plan marked out there, right? You just dropping the mic and there you go, I'm out.
run away.
Alright, linear pair. Linear pair, two angles next to each other. And they're not common sides form a line. David, what's a relationship between angle 1 and 2 as an example? Other than the fact that they're a linear pair, let's not go down that path again.
They add up to 180 degrees because they're on the same line.
Beautiful. Which is same would be true for angles 2 and 3, and 3 and 4, and 1 and 4. Now, if we were doing this backwards, we could use that information to prove in the previous slide that angles 1 and 3 are congruent, but we didn't. We took a different approach. We're good to go. Okay. Linear pair. They're called a linear pair because they're on a line, and there's two of them. Solve that example. And notice I'm asking you for two things. I'm looking for the value of the variable x, and I'm also looking for the measure of angle CAT. For discussion purposes, I'm going to throw a couple more labels in here. Let's call this D and this S. We might want to discuss that when we get down to it. As you're working through this, let me give you a couple hints. The first one is that the first question you should ask yourself is, what pair of angles am I looking at here? Once you know that, the next question is, what's the relationship between those angles? The answer to that question will then tell you what to do with the algebra. Do I set them equal? Do I add them up and set them equal to 180? Then obviously you solve, and then the last part will be making sure you answer the question, or questions, as they're also outlined in this problem. And as always, once you get an answer, check with your neighbor to see what he or she has. And then feel free to argue if you're not on the same page.
Something's wrong with my calculator.
No, I have to work tonight.
I need like the stuff in my messages and now it's like,
What are you looking at?
it's just not here.
Can't leave it blank, otherwise it goes. Bella, what do you got for X?
I don't think it's at 12 and
That's okay if you're wrong, right? Your brain will grow.
yeah.
12 and a half?
Yeah.
12 and a half?
I got 6.7.
So that either means you did it wrong or they're scared that they did it wrong. What'd you get, Nick?
6.75.
6.75.
That's
Yeah.
it.
Yeah.
Okay, so let's start with you, Bella. What'd you do?
I did 16x minus 20 is equal to 180 to try to find the half of the sum.
Okay, so does that angle equal 180 though?
No, it's a straight line.
It would be a straight line, right? But this isn't a
Yeah,
straight line,
but
so
I'm
it should.
just trying to figure out that measure of that angle.
This angle?
Yeah.
Okay, but you gotta use these two together in order to find it. Okay? What did you do?
I did 16x minus 20 equals 12x plus 7.
Why? What kind of what pair of angles are those two?
Vertical.
Vertical. And we know the vertical angles are equal.
Yeah.
Okay, so you did 16x minus 20 is equal to 12x plus 7. Okay. What kind of angles are they? They're vertical. What do we know about vertical angles? They're congruent. Therefore, set them equal, solve, what'd you say it was, 6.75?
Yeah.
Okay, then what?
I didn't do anything from there.
Braxton?
Then you plug x into one of the points and then, or one of the
Angles.
angles. Yeah.
Which one?
I did 16x minus 20.
Okay, so you took this, brought it up here, plugged it in there, and found out that angle is how big?
It's 108 degrees.
108?
Yeah.
Okay, 108, yep.
And then
How big is angle SAT then?
angle, oh wait, I thought we were finding.
We are,
Oh,
I'm
wait,
just asking
it's
on
108 degrees.
Also 108 degrees. And therefore, how big is angle CAT?
72 degrees.
Why?
Because you take one of the angles and subtract it from 180 to find the other angle.
What kind of angles are DAC and CAT?
They're adjacent angles,
Good, and?
linear angles.
Good, linear pair. Okay. Problems? Question?
I got 88.
Yeah.
Yeah.
Uh-oh.
6.75 minus 20.
Dissension in the ranks? Who got 88?
It's obtuse angle though.
Man?
Yeah.
Oh yeah, maybe I forgot.
16 times.
You forgot to subtract the 20.
Oh, my bad.
Okay, hold on, let's fix this then. So, you're saying that, Camilla, right? Yeah. So you said that this is 88, and this is 88, which makes this 92. Oh, Rexton, back to you. What's wrong with that?
Well, the 92 degrees is an acute angle, so it can't be more than 90. And then that's an obtuse angle, so it can't be less than 90.
Happens all the time. You understand the problem?
No.
Solve this mathematically or algebraically, I should say. It tells us that this is an acute angle, but obviously from the picture, it's not acute, it's obtuse. This is an obtuse angle, appears to be acute. So the question is, which one do you trust? Do you trust the numbers or do you trust the picture? No, numbers every time. Okay.
Then what's the point of the picture if it's wrong?
Just to
Really
show
well.
the visual.
Just to show you the visual where the angles are located. Sometimes life doesn't make any sense.
I don't like that.
Okay, I'm sorry. I don't know what to tell you. You'll be okay though.
I'm not.
Fourth type, supplementary angles. Anybody know what supplementary angles are?
I heard of it.
Data.
Two angles that add up to 180.
Good. And that's it. There's no catch to that. They're just two angles that add up to 180. Those angles can be anywhere. They don't have to be adjacent. They don't have to, there's no stipulation. It's just one added to the other equals 180. Wishby? Yes, Mary?
Is it complementary angles?
Hold on. Slow your roll there, sister. That's a click away. Going back to the other angles we talked about that, notice that a linear pair are also supplementary. So a linear pair is adjacent, it's a linear pair, it's also supplementary. They are. You think somebody planned all this out? I do. Gesundheit.
Plus,
Complementary angles are what, Mary?
Angles that add up to 90.
90. That's all 5 pairs of angles. Now let's do some examples, or some more examples. Why did some people groan on that?
I cheered.
You cheered in your head, or because I didn't hear you cheer out loud.
It was very quiet.
Very quiet.
Oh, yeah.
Okay. A muted cheer. Nancy.
Why would it be if like three or more angles add up to 180?
No special name. Okay, so these are always pairs. That's a good question. With regard to what Nancy just asked, go away. If I draw a picture like this and label this 1, 2, and 3, angles 1, 2, and 3 are not supplementary. Supplementary is only a pair. These are just 3 angles that happen to add up to 180. Okay. Good question. All right, find the value of x to measure the angles in that picture. What pair of angles do you have? What's the relationship? What should I do with the algebra? Solve the algebra. Answer the question. There are certain things in the picture that you can trust. So in this problem, for example, you can trust that angle HIJ, hippopotamus, iguana, jaguar, is a straight angle. Hey everybody, it's Mr. McDermott.
Hi, Mr. McDermott.
Wow. Whoa. Could you step outside for a second?
Right out here.
Just, right, yeah, give me a second.
Okay.
All right, how do we handle this, people?
We
Thumbs
say-
in, what do we say?
Hi.
Mr. McDermott,
I
not
thought we-
whoa. All right, come on back in.
You sure this is all right?
Yeah, we're good. Hey everybody, it's Mr. McDermott.
Hi, Mr.
McDermott.
Better, good, you're learning. You
That was great.
coming in to chill?
I'm gonna come hang for a few.
Oh, that's
Gonna play with your,
We have a
all
guest
kinds of
in
stuff
there.
on your desk.
guest visitor. Okay, good again. Good again. Sorry, let's try English this time. Again, if you, or when you get your answer, not if, let's think positive. Check with your neighbor to make sure they have the same answer. If they do, high five. If not, fight about it.
I am finished.
And don't assume that all answers are going to give you, or all problems are going to give you pretty answers. You're not always going to get things like 3. Maybe you'll get a decimal. Ooh. Maybe a fraction. Maybe both.
Ooh.
Oh, that's not pretty.
It is pretty.
You got a pretty answer?
I got
I got a pretty
No,
I got it wrong.
Bella wants some redemption, so we're going to call on her. Bella, what'd you get?
X equals 13.
X equals 13?
Yeah.
Woo. Tell us how.
I 10x minus 5.
Hold on one second. Who was that? Jack, we need a therapy session, or are you good? You gonna work through it? Okay, good. Sorry, Bella, back to you.
I put 10x minus 5 plus 4x plus 3 is equal to 180.
Why? What kind of angles are those?
They're the two angles add up to 180.
Which is called? The meal after lunch is supplementary, very good. What other kind of pair of angles are those?
Complementary.
Nope.
There's a straight and then a complementary.
Supplementary, not complementary.
Yeah.
What other kind? Good. And the third? Also a linear pair. Okay, so you did 10x minus 5 plus 4x plus 3 equals $1.80. Solved it for x, blah, 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 blah. What'd you say, 13?
Yeah.
13. I'm guessing you can all do the algebra there.
yes.
Good. How about the measures of those angles? Then what do you do with the 13? Bella?
You plug it into 10x minus 5.
Uh-huh. And
then
get?
125.
Uh-huh.
And then you put it into 4x plus 3, and that equals 55.
How do I know she's right, other than the fact that the rest of you just argued that she's right?
You add 125 is 55 and you get 90.
Good. All right, so we're back where we started. Nicely done. Okay, next one.
It's a different picture. Oh,
This is too hard.
You're not gonna start crying, right, Sterling? But I bought new Kleenex today.
Oh, you did?
Yeah, so we're good to go. What kind of angles? What do I, these are rhetorical questions, though, don't answer me.
Oh.
What kind of angles? What do I do with the algebraic expression? Solve for x. Answer the question. All right, we good?
Yes.
Yeah, you sure? Jenna, what do you got? X equals 29. Okay, thank you, that's all you need, good. I got nervous there for a second. And how big are the angles?
Oh.
Oh, good answer, yeah. Did you get the individual angles? Well, how big are they? 60 and 30, yes?
Yes.
Beautiful. So, what kind of angles are these, Jenna? Yes. What other kind of angles are they? Beautiful. Complementary. So what'd you do with the algebraic measurements?
I added the two equals together and had them equal to 90.
Magic happens. X equals, what'd you say? 29. Sí. Gracias. And then took this. Now, did you plug it back into both of them? You take that and plug it in here and over here? Okay, good. Also notice, however, if I have a little bit more confidence in my solution, I could take 29 plus 1 and get 30, and then do 30 minus 90 to get 60 there.
90 minus 30.
You said 30 minus.
I did not.
Yeah, you did.
We'll see on the recording later.
Oh, great. Did you put the video up yet? I want to make sure you're wrong. Oh, I might lose that recording. Okay, now it gets a little more difficult. No picture to work with, just words.
No, not word problem.
Before we get into this problem, though, let me ask you a question. Suppose I have a 20-degree angle. We have something called a complement, and a complement is the thing that you add to that angle to get 90 degrees. So what would the complement of a 20-degree angle be?
70.
70. Beautiful. What's a supplement of a 20-degree angle?
70.
160. Good.
70.
Okay. He was close. Okay, so that, starting with an angle measure, it's the number you add to it to get 90 is a complement. The angle you add to it to get 180 is a supplement. Everybody good? What happens if I start with an angle x? How big is the complement to that angle? Okay, so think about the process you went through to find the 70-degree angle. What did you do? Nancy? I didn't hear what she said. 90 minus x, good. And what would the supplement be? Rexon?
180 minus x.
Beautiful, good pattern recognition. Okay, you got that? If you remember this, or understand this is a more important thing, these problems are easy because all you need to do is literally write down exactly what it says. Okay, I'll show you. The measure of the supplement of an angle. How do I express that? 180. No. How big's my angle? Nope. Do you have any idea how big it is? So what should we call it? X works just fine. So if X is the angle, how big is its supplement? Good, 180 minus X. The measurement of the supplement of an angle. That takes care of this. Then we got this little is thing. And in the math world, is becomes an equal sign. Is, or equals, 60 less than. What mathematical function is less than? Subtraction. So we're going to end up subtracting 60 at the end. So that takes care of 60 less than 3 times the measure of the complement. 3 times, how big's the complement? Max? 90 minus x. That's the hard part in the problem, is writing the original algebraic expression. The algebra shouldn't be that bad. Answering the question shouldn't be that bad. It's getting to that point. And so again, you need to remember that 90 minus x is the complement if you start with an angle x, and 180 minus x is a supplement if you start with an angle x. What's the first thing you do solving that equation? Distributive property, good. Solve for x, move stuff around, blah, 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 find your value. Okay. When you're done, not only should you answer the questions, but ask yourself another simple question. Does my answer make sense? Suppose I get an answer for x like 10. Does that make sense? Can you have a 10-degree angle?
Yeah.
Good. Would it have a complement?
Yeah.
Would it have a supplement? Beautiful. What's a value of x that wouldn't make any sense?
Negative 2,782.
Excellent. Negative 2,782 would be bad for 2 reasons. Why?
Because it's a negative and
Good.
it's more than 360.
More than 180. Remember, we don't deal with anything bigger than 180 in here. Good. Okay. All right. So you'll see a couple of these tonight. But again, make your life easy and just write exactly what it says. Solve and then answer the question. We're running out of time here, so let me make sure we get the slideshow done. Perpendicular. You know what? I'm going to save this for tomorrow. So if perpendicular, you probably all know what perpendicular lines are. If it pops up on the homework tonight, do the best you can. We'll do some damage control tomorrow. Sorry, not tomorrow. Tuesday. You guys have been working so hard. I'm going to give you Monday off.
Thank you.
You're welcome.
Day 7 for us.
You're so
See you.
Who else?